Okay, hello everyone. I am back with my second part, and I have done some resources. I have created some art, some assets in Inkscape. Uh, this is gonna be the background. This are the blades, and this is what come the ammo of the robot. The robot will throw these to attack. This is the floor in the jungle. And these are the frames of the robot: the first frame, second frame, third frame, fourth frame, fifth frame, and again. This is what I am able to produce in almost 5 hours time. I am not a good artist, I know. So what I have to do is we're now making a first level in first level with these things. So first I am going to create a new class called resources. This class is going to manage all our resources that are used in the game. E- Everything here will be public and static. So public static texture background, public static texture blades, public static texture floor, and the rest of the robot things is animation. Public static, not the effects, pencil, okay. Animation robot. Okay. So now there is a init method, public static void init. This will init the resources, and public static void dispose. This will dispose the resources. So in the main, in the init thing, we're going to resources resources.init, and in our update, sorry, dispose my function, we're going to dispose the resources. So here I'm going to use the resource loader. So disposing is easy. Resource loader dot get instance to dispose. This will automatically dispose all the resources that were loaded using the resource manager, and get the loader. Resource loader is equal to resource loader dot get instance in background id is equal to loader dot define texture resources background web png int blades id bid loader dot define texture resources blades dot png int floor id is equal to loader dot define texture resources flow underscore jungle.png, and finally now comes the robot textures in rb1id. The robot 1id is equal to loader dot define texture resources promo1.png. I'm going to copy this. 2, 3, 4, 5. 2, 3, 4, 5. And yeah, 2, 3, 4, 5. So we have defined all the resources. Now loader dot start loading. And after we have loaded, we have to get back and assign to our variables. Okay. Background is equal to loader dot get texture bgid. Next, blades is equal to loader dot get texture bdid. Next, floor equal to loader dot get texture floor id. Next thing is the robo. We are not storing the robo textures directly, but we are using an animation object. So let's create an animation. Robot is equal to new animation, and it will take some callbacks. Okay, let's just use the default callbacks for now. Robot dot add frame, loader dot get texture rb1 id, and this length will be, well, 100 milliseconds. So we get 300 milliseconds, and this unit is unit dot millis. The we can use any time unit we want. So the next frame, okay, I'm going to copy this. 2, 3, 4, 5, all with the same. Okay. RB 2 ID, 3 ID, 4 ID, 5 ID. This should work. 2, 3, 4, 5. Now we have the final animation. We're going to specify how the animation should behave. Robot dot set end callback. We just restart the robot. Robot dot start. Okay, it can be replaced with lamp method. So every time the animation ends, the animation will start again. We simply keep the robot starting. This is a simple game. And now that we have the resources, let's try to draw the background. Forward public void render batcher float filter. Okay. So delta batch. Okay. Now what we have to do here is we'll get an instance of graphics studio. This is not the AWT graphics studio. This is my custom implementation that uses OpenGL to render in the background. So graphics studio G sorry 2D is equal to silence engine dot graphics dot graphics studio. Now I'm just going to draw the background all over the window. So g2d dot texture, it is resources background, starts at 00 and ends at display width, display height. So now if you run this, sorry, if I run this, okay, it started in back. Okay, we have a background. So this is our background in the game. This black here is not, you won't see in the resource, but here it is transparency and not white. So it's producing a good effect for me. Okay, what I actually want to do is implement game states here. So let's add a new package called states and a new game state called play state. Okay, again there's okay. This play state extends from game state and let us move the render from the main to the play state because we want different states to render different things, and after resources are initialized that game state to new play state. So yeah, this is exactly the same. Now what I'll do is we'll create a sample scene now. So we'll be loading our scenes from a text file. So levels, this is another new package and I'll create a level1.lvl. Okay, the ones that start with comments are that starts with hash symbols are called as comments in this format. Okay, so F stands for the floor. So floor. Okay, but before just passing the level, we need entities. So new package entities. The first entity we are creating is called is floor, obviously, and this flow extends from entity to D. Okay, so I will add a constructor public floor, and it will take a 2D vector position super. It should inherit with a new rectangle for the collision. So the width is same as the textures width. So resources dot flow dot get width, and the height is resources dot flow dot get height. Now we are setting the position to position. The position that we have used it here. App is ready. So in play state, we need to add some variables. Private, private, in, scene. It is the scene. Private 2D scene collider, scene collider 2D or collider. Now in the constructor, public play state, we are going to create the scene equal to new scene. Scene not init, collider is equal to new scene collider, and it needs a broad face to cull the entities that are not being collided. So to remove them from checks, so I will be using an AABB tree, new, so dynamic tree. So that's it. Collider is ready, and collider does set scene to our scene. So this set the collider automatically. What we have to do is we have to parse the level from the LVL file. So private void load level string resource name. So we are loading this level here. Load level. Okay, wait a minute. I will make this levels as in the source factor. Levels belong to the source. So it will be easy. Okay, I forgot string. Levels level1 dot lvl. So here, and by the way, we need an update also. Void complex void update load delta. So we are just going to do scene update delta and collider dot check collisions. Next. Okay, now we have to read from a file called resource 9. So I will use the file utils dot read lines to string array, file utils dot get resource name, and it will return a string array, string lines. So all the lines in this text file are now in this array. So we need to keep two variables here. Float x equals 0 and y equals 0. Now let's start one line for each line in lines. Or We colon expected. Okay, okay, I forgot to type this string. Okay. For each string line in lines, get iterate over every char. So we have to omit if this line starts with a hash. If line dot starts with a hash, continue. Next, or else for each character C in line dot with char array, we'll just implementing the X positions here. So we will first so switch C case case F the flow C not add child new flow and starts with a position so new vector 2 and it takes x comma y so increment the x plus equal to this is flow so resources dot flow dot calculate so that's okay and now break and now here we have to increase y plus equal to let us hard code this value here 163 163 okay so this is doing load our level so now if you run this okay what has gone wrong everything is being rendered but actually what we did is we didn't we are not drawing anything in the flow so draw public void render load delta batcher batcher and we have to get the graphics studio g2 is equal to while in the graphics studio g2 dot draw texture resources of flow at our position so now it should render so something wrong is happening here okay flow is not drawing so okay let's go to play state okay we are not rendering all scene dot render delta batcher so it should so flows there something is happening okay it simply goes so y plus equals 3 and X equals 0. It should come back after the row. Not still. Level is loading. I had no idea. Let us debug this. Okay. So when the resource is this, the line is hash stands for flow. So continue. The line is empty string. So here. So y is 163 the next line. So line here is empty string again. Y increase. Line empty string. 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 Y increase. Okay, it is going too high. Non very higher than limit. So let's reduce the height. Okay, it's still more. No. Okay, yeah. So yes, it is rendering nice, but the size of these tiles is very high. This is vector or so I have to manually resize these entities. So we'll stick to 30 to 48. 48 by 48 and get y 48 48. This is going to be our position. Now I'm placed it. Going to add it by 48 and by y by 40. Now we see it should be cool. Okay, it's good enough. So let's get it back to the bottom of the screen. So plug it. Okay, now let's see. Still not sufficient. Okay, now I think it will go overboard. Oh, so we can move it back still two rows. Now if you see, it should be there on the bottom. Resize and it's it. So what we have to do is we have to prevent resizing. I mean, prevent the scene so that the graphics studio camera is also resized, not resized. Forward public void resize. since this resizing will affect the whole game, I'm going to move it to the main class. So here, get the graphics studio. G2D is equal to search in the graphics studio, and then C2B dot first cam is equal to G2D dot get camera. This is the automatic projection camera, and we have to resize it to the default size. Otherwise, it automatically resizes whenever the window is resized. So cam dot init projection, the width and height. I'm going to make it as 800, 600 constant. So now it's this. And now if you resize, the game also resizes. Pretty cool. Okay. So now we have to create one more entity, the robot actually. The robot extends from entity 2D and manage. So it also has a constructor that takes a position. Import new rectangle, and we have to think it as 2 squares width 2 times 48 by 5 square height. This is because we are resizing the entities directly in our code. So set the position to our position, and now forward public void update. This is where we are updating this entity. So every time we update your entity, we also have to update its animation. So resources.robot.update and pass in delta. This will detect the frames and object void render float delta and batcher. Okay, so here get the graphics studio again. Studio is equal to graphics studio, and now we're simply drawing the texture. G2D.draw texture. This texture is returned by the robot animation get current frame, and the position is get x, get y, and the size 2 times 48 and 5 times 48. Okay, now in the level, add a new comment. R stands for the robot, and it takes 5 cells. So 1, 2, 3, 4, 5, and add it here. So now go to the main state. Okay. Case F, case R, scene.add child, new robot, new vector 2, x comma y. Okay, this x is common incrementing. So let's move it out of the switch case. Okay. X plus equal to what? One cell, no break. So now if you run this, you see this robot working. Yeah, let's keep it next switches. Okay, good. So thank you for watching, guys. This is the end of the part 2, and in the next part I will be making some enemies and we'll throw the blades. We'll add space key as an attack to that throw the blades, and this animation will only be updated when we are moving. So that's an idea, or that is when A or D is pressed. So this is the end of this live event. So thank you very much for watching. If you like this, please like, comment, and subscribe. So thank you for watching.